And really, these are problems of scale. And so when I think about things like migrating software, right? Anyone can change a line of code and change 10 lines of code, but how about changing 10,000 lines of code or 100,000 lines of code in a reasonable time? Those are kinds of the problems that we start thinking about working on systems of this size.
Hey everyone, welcome to Dev Interrupted. I'm your host, Dan Lines, and today we are talking to Hyrum Wright and Titus Winters. Hey guys, thanks for joining the pod today.
Thanks for having us.
Great to be here.
Yeah, awesome to have you both. So I want to give our audience some context before we dive into your book, which is a great book. And let's start out with Hyrum. So Hyrum, you're semi-famous for being Hyrum of Hyrums Law, which we'll get into a bit later. And your focus at Google is on large-scale code change tools and infrastructure. Can you give us a quick kind of high level of what that actually means?
Sure. So Google has hundreds of millions of lines of software, source code, and as a strategic goal, we want to make sure that is maintainable, that it's fresh, that we can sustain changes that we need to make to that code base, whether it's a business reason or a technical reason, a new library standard, new library, or new language standard, new libraries, whatever it may be. We want to be able to evolve our software to meet those needs. And so to do so, we've developed a number of tools to make that happen at scale. And that's a lot of what I do, is help the people that are developing those tools do so, to understand what are the needs that the business is going to have in terms of being able to evolve software longer term. Try to think about new strategies for doing that, and just make it so that we don't have any hidden corners of our code base that people are afraid to touch. We want to make sure that we can always evolve our source code to account for changes in the needs of the business.
Okay, awesome. That sounds like a really great job. And Titus, I read somewhere that you're in charge of something like 250 million lines of code. Over 12,000 developers work on this code. What does your role as a senior staff engineer look like at a high level?
I don't know. Someone was going to tell me that someday. No, but largely I have my fingers in most things that pertain to how people write C++ code at Google. So like the teams that I directly manage maintain Abseil and our internal common libraries, like Google Test, things like that. So a lot of the nuts and bolts, I describe it as if all of Google's code base was a book. My teams are the ones that provide nouns and verbs. We are the nut. But I also work as one of the C++ style arbiters. So I produce the C++ style guide that Google uses and that we provide an external drop of. So I control like the way that you like format that, the way that you like what features are allowed, which features are encouraged. I have my fingers in a lot of the like best practices, the tips of the week, things that aren't law like the style guide, but just this is probably what you want to do unless you have a really good reason otherwise. A lot of education, training. So it really runs the gamut from the very, very low level of maintaining the mutexes and the data structures all the way up to the very people-centric, like we need to answer several questions a day on, hey, why is this crashing? Hey, can you help me debug this? Hey, I need to understand this better. And that's, so we're the care and feeding for 250 million lines of C+ code and all of the engineers that go into that.
Wow, that's awesome. Yeah, being responsible for 250 million anythings is really a really cool job as well. So the book we're talking about today is commonly referred to as the Flamingo book, but actually titled Software Engineering at Google, Lessons Learned from Programming Over Time. So Hyrum, would you mind giving us a quick intro to the book and how it came to be?
Sure. So we have been talking, and by we, Titus and I and other people at Google, we've been talking about our internal development process externally for a long time. You can go find conference talks on YouTube, you can go find a lot of things like that. But we kept finding ourselves saying the same things over and over again, and talking to an audience that was just skeptical about the way that these things actually work in practice, and how we would apply large-scale changes across our entire code base in some like reasonable amount of time, or how does the build system work in an organization like Google, things like that. What actually ended up happening is I left Google for a little bit, came back, and when I came back, I didn't have anything to work on. Titus is like, hey, I have this, we should write a book. And I'm like, hey, sounds good to me. I don't, know how hard that will be. So like, why not? It turned out to be much harder than we expected. And we ended up crowdsourcing much of the content. Like, we aren't the domain experts here. And we ended up finding people within the company who are the domain experts and working with them to help get much of the content. So most of the words aren't actually written by us. We did write several chapters, but we helped make sure that it speaks with a common voice and did a bunch of the editing along with Tom Mantrek, who really did a lot of the technical writing and editing work. We'll make sure he gets some credit here. And really, this gives us the opportunity to have a reference that we can then talk about. What is it that makes software engineering at Google different than lots of other organizations? And it's not that we're trying to convince people that they need to do it the way we do it. It's more just, here is the problems we have faced, and here is how we have chosen to solve those problems. And you may choose to solve them differently, but you will probably encounter similar problems, and hopefully our solutions can help you as you chart a path through that problem space in your own organization.
Go ahead.
I like to describe it by analogy. They say Lewis and Clark explored the Louisiana Purchase, by which we mean they took one path out and one path back, which is not exactly mapping, but in a very similar way. Like, there's not a lot of organizations that have ever operated at this scale. And so we're trying to give an exploration trip report map. Hey, there's mountains here. Did you know? And it's going to be, other people are going to come along later and fill in some of the gaps, but hopefully we can at least point out where the Rockies are, and hopefully people find that useful.
Yeah, for sure. There's so much knowledge to be shared, and Google is always, you think of it as like the biggest scale on the planet, or maybe got challenges that not many other humans on the planet have faced yet, but might face soon. So you're going to get a lot of popularity there. I definitely want to dive into the three main themes in the first chapter, the first being time. So Titus, can you talk to us about the role of time in relation to software?
My favorite quote, which I think I didn't actually find this quote until I had started writing the opening chapter, is Dave Parnas. It's probably Dave Parnas, this might be apocryphal, back in the 70s said, software engineering is the multi-person development of multi-version programs. And that means that for 50 years, we've known that this is about teamwork and time. And I think that's very wise. My sort of pithy version of this was software engineering is programming integrated over time. There's a dimensionality difference in there that I think is really critical for people to realize. And schools, CS programs, all of this, we're training you as a programmer, and that's great. But there's a whole other dimension that's going to pop up here. Like, squares are not cubes. Velocity is not acceleration. Software engineering is not programming. They're related. They have a similar shape to them depending on how you squint. But like, all of the hard stuff comes because of time. Like version skew, backwards compatibility, like issues with data storage, schema evolution, right? Dependency management, upgrades, all of the things that are actually the really hard stuff, they all have one root cause. Time is the enemy. And so the more that you can really be aware of that, the more that you can admit that, and the more that you can find ways to make your things time invariant and take that dimension of complexity out of the problem, like the better off you're going to be. But if you're just ignoring it, then you're going to have a problem, especially if your code starts getting into the point where it's going to last 3, 5, 10 years. You could probably get away with not worrying about upgrades and change in time too much if you're going to throw it away in a year, 2 years, 3 years. But a whole lot longer than that, and you need a different approach. And I didn't see a lot of people talking about that fact. So time underpins everything.
Yeah, I can definitely relate to that, especially for new, let's say, programmers in school. It's really hard to, I think, simulate time or experience. How do you experience time without actually doing that? So I assume with this book, maybe you can read a little bit. If you're more of a junior, can get some of that knowledge. I know Hyrums Law plays into this time pillar. Hyrum, can you talk about what Hyrums Law is, how it came to be, and what it means in regards to time?
I can do that, yes, certainly. So I'm laughing because Titus is smiling here because he's going to know that I'm going to blame him for much of this. So Hyrums Law is the observation that given enough users of your program, system, API, fill in the blank, it doesn't matter what you actually promise in the documented contract, all observable behaviors of the system will be depended on by somebody. And the classic example of this is if you have a dictionary data structure and you're iterating through the things in that data structure and you expect them to come out in a certain order. Now, from a purely theoretical perspective, a dictionary doesn't keep things in a ordered format, right? In a practical perspective, it has to order things somehow, and oftentimes it does so consistently. And so you can write programs that depend upon that ordering. And so that then constrains the author of that data structure in their ability to evolve it in a different way. And that's really what this comes down to. I will point out that number one, I did not name it. I will blame Titus for naming it. And number two, the idea isn't actually, in some senses, it's not actually that new, or at least doesn't feel that way. I just put it in a succinct format, and then that kind of, Titus gave it a name, and now people can call this idea a thing. I've been rereading The Mythical Man Month, and Brooks talks about this concept several times 50 years ago. So this is not a novel thing from that perspective. But really, within Google, it came up because we were trying to evolve parts of our system. And I kept running into places where somebody was depending upon a certain part of the system, which you would not think anyone should depend on. I changed the comments in a header file, and all of a sudden tests start breaking somewhere. And you think, wait a minute, like that doesn't change the parse tree. It doesn't change anything about the software. Like, why would tests start? It turns out that people were depending upon the line numbers that were emitted by log messages. And if you change comments and you add lines there, it will throw off the line numbers, and tests will start breaking, because that is an observable behavior of the system. And so that kind of started off as an internal rant, and then we refined some of the ideas, and then it became a pithy saying, and now it has its own website. That's the evolutionary process of Hyrums Law.
That's awesome. And Titus, that's really cool that kind of you're the one that said, hey, we should name this Hyrum, and we should name it Hyrums Law. Any perspective from you of like why you wanted to get that knowledge or that law out there to the world?
Like, I totally agree with what Hyrum said. This is not novel. Like, I've had plenty of old timers and software engineering profs and stuff say, oh, these Googlers think they're inventing new stuff. Like, no, I'm well aware that we're not inventing new stuff, but it's also really important to have shorthand for concepts so that you can incorporate that in discussion and not have to go back and re-explain and argue over terminology and stuff. And so I think a lot of the, like, one, it's incredibly true, and I would actually classify it as, a like thermodynamic level truth of software engineering. But at the same time, too, the important part is give it a name so that we can agree on the terminology and conceptualize, put it in a box, build on it, move on. So, yeah.
I read it. I found it to be a great piece of knowledge. Like, let's say I'm building an interface or an API, just expect it's going to be used in all these different ways. If you go in blind and say, hey, I built this interface, this is the law, that mindset could get you in trouble down the road. I had a nice takeaway from it. Thanks, guys, for putting it out there.
The other point on that, if I may interject, is that just because a law exists does not, or we call it a law, does not mean there aren't things you can do to mitigate its effects, right? So the law of gravity is a thing, and yet we fly airplanes, right, that look to defy gravity in some senses. And it's not really, it's like we're mitigating the effect of gravity for using some other knowledge we know about. And with Hyrums Law, if you're building an API and you expect that users will abuse it in ways that you don't know, you can take steps to hide behavior, to do better encapsulation, right? To understand that even if you document certain guarantees in your API or your system, right? I'm using API very generally here, that you can build your system in such a way that fewer behaviors are exposed, and thus fewer people can depend upon behavior inadvertently, right? And just having that conscious awareness will help you build better software.
Yeah, absolutely. Great insight and great point there. Titus, before we move on, I was hoping you could repeat for our audience something that really kind of stuck with me during my research for the episode. What is the real goal of software engineering?
The real goal, it's not to sit down and write code. It's to solve problems. We happen to do that with code, but producing code is counterproductive. A way that I saw a while back that I really like to view the problem. Aeronautical engineers don't view the job as how much aluminum or titanium can we use. They view the job as how little can we use to get someone safely from place to place, right? And you get all of these snarky sorts of quotes of every line of code is a liability and it's not lines created, it's lines spent, which, doesn't really feel snarky. But there's a truth in that, which is the goal is not code. The goal is problems solved, and like you happen to do that through code, but all of the code that you have spent is a liability and is a thing that you're going to have to maintain, is a carrying cost.
Do you look at it that way of, hey, we're here to solve problems because it will set a developer up with a better mindset to make better decisions? Or what do you think that type of mindset does for a software developer?
Ideally, I prefer the term software engineer, because even when we just talk about developer, like the idea there is that your goal is I'm developing a new thing, whereas engineering being the whole like life cycle and the whole management and the like, I'm just going to keep it running, tune this up a little bit. You spend a lot more time, if you really internalize this, I think you spend a lot more time reading and talking and asking questions, probably answering questions, and finding the existing system that almost does what you need, and then making a couple small tweaks, instead of the much more satisfying, spend 3 weeks and build an entirely new thing, and then you have two competing solutions and a problem. And that's really what I want to encourage more. And certainly Googlers have a lot to learn on that front. We're as guilty of that as anybody, but that is the mindset that we usually want to encourage.
Yeah, all good. We're all here to improve. Moving on to our next major pillar, which is scale. Hyrum, I'd like to start with you on this one. How does Google think about scale, and why is it a major pillar?
When I've talked to people in the past in university recruiting and different things like this, I actually would talk to them and say, like, lots of Google's problems aren't actually problems of kind, they're problems of scale. Email existed before Gmail did, right? Web search existed before Google search did. You can pick a number of different technologies that existed before the Google thing came along. But no one had a gigabyte of email storage before Gmail came along, or whatever the obscene number was at the time. And really, these are problems of scale. And so when I think about things like migrating, so anyone can change a line of code, and change 10 lines of code, but how about changing 10,000 lines of code or 100,000 lines of code in a reasonable time? And those are kinds of the problems that we start thinking about working on systems of this size. And really what this means too is if you scale over time, so we're not just talking about like a snapshot at a specific moment, we're talking about how does the system evolve over time? How does it scale over time? And again, if you're working in cloud computing, if you're running, like, you're going to be thinking about these things. I have to provision more machines for the future, for the growth of my service. I have to provision more network. Hopefully I'm getting more traffic into my service, these kinds of things. We sometimes don't think a lot about the provisioning of people, right? If my code base doubles in size, do I need twice as many release engineers? Do I need twice as many kind of like operations people to keep the version control system running, or maintaining the libraries or the build system, or all these kinds of things that are fundamental to the process of building software? How does that scale, right? In the concept of people effort, right? The amount of effort required to make that happen. And really the key point is that if you can't scale sublinearly, if you scale at or above the rate at which your code base is growing, then at some point you're going to consume all your resources just standing still, right? Like, you're not going to be able to work on features because you'll be spending all of your time just doing kind of maintenance work. And so the core insight here is make sure that you build your processes in a way that allows them to scale sublinearly, so that when the size of the code base doubles and you're doing releases 3 times as often, that you don't have to have 6 times as many engineers. That you can build tools and processes in place to make that happen.
Yeah, like similarly, it is about people. But similarly, another example, if I was, working at a place with 5 or 10 engineers and was the in-house C+ guru, I would spend a lot of time pair programming with people and spend a lot of time like doing the detailed code reviews on all of their things, and that would probably be the most effective way to use that expertise. Since there's 12,000 of us instead, if I want to make people understand a thing, it's not effective for me to go to every engineer or every TL. Like, I need to write it down, and then I need to have systems in place where I can try to get that written version of it surfaced at the right time. And so we're just going to approach the problem in an entirely different fashion because of the realities of there's just a lot of people here.
Yeah, some of this, I keep going back to a mindset. Okay, let's not consider ourselves software developers. We're software engineers, and scale at this magnitude that Google does. It almost feels like I need to step back take a holistic approach, maybe look at these problems from a few different perspectives that I might not be used to. Is that a process that you go through? Do you sit down, let me look at it from this angle and that angle, or like, was that an evolution for you guys? How does it work?
I think we fell into it. Like, a lot of it was like, the one thing that Google is very good at is not accepting how everyone else does it as the one true way to do it. Like, we are pretty good at that. That clearly isn't going to scale as we get twice as large. We're going to have to find something else. And I'm not sure that the thing we're going to find is going to be better, but at least we'll learn something. But it is pretty reactive in a lot of cases. And I don't think it is nearly as clean and elegant and thought out as it might look from the outside. Like, there's a lot of stumbling around going on here. But
yeah, it's easy to look, like most historical things, we can look back and say it's a foregone conclusion that this event followed from this other event. And it's not often the case that the people in the moment at the time had any idea what they were doing. I mean, that they were intentionally working towards that specific outcome. And I think for us, it's been a decade of kind of trial and error and finding out what works and finding out what doesn't, and trying to collect the things that work and institutionalize them and move on to the next thing. It's not as straight a path as many people think.
Yeah, absolutely. One point that I do want to hit on, I think, Hyrum, you might have mentioned it, around the sublinear resources. So I'll throw the question to Titus, because I think it's one of the major, points in the book here. But can you talk about consumption of sublinear resources? What does that mean? What is that all about?
let's see. The most important way to look at that, I think, is for all of the processes that go into writing your software, how often do you need to do something that is scaling in terms of the number of engineers? And so, like, in a very small company, it might be fine to be like, hey, I'm going to send an email to every engineer and say, no one check anything in for an hour. I'm about to do a big crazy thing. We don't have that option. It is maybe once a month that an email goes out to all eng to say, hey, there was a bug, make sure you don't release between these points. And the rest of the time, everything has to be done with no coordination. And building it, or whatever coordination is there, has to be purely technical. And we are vastly more willing to spend a ton of compute resources in order to ensure that we don't need a constant or growing fraction of our human effort to be spent doing the same tasks. So, for example, a story that I tell in version control, companies that I worked at before I was at Google had not rare sort of policy of lots of teams had long-lived dev branches. And then we would have a meeting, once a week to be like, okay, which teams get to merge this week? And then there was one guy whose job was do that merge and retest everything and see what's actually still passing and see if that merge stayed. And when we got up to 200 people on that project, one guy was not enough to do the merge. And so we have all of this overhead of testing and resyncing and rebasing and all of this stuff. And instead, Google realized there's no way that this scales, because even adding a second guy to that, now those two guys have to communicate and coordinate. This is not going to be linear. Instead, so we have this whole monorepo thing. Everyone's building it ahead, and we replace all of that merge and everything with continuous integration and better unit tests and auto rollback and feature flags and experiment. And it touches everything from pre-submit testing all the way out through production, when you toggle which features are enabled in your release. But all of that code is there. And that changes the model entirely into something that feels much more risky and chaotic, but in fact actually works much more smoothly. It's the difference between riding your bike slowly and riding your bike quick. There's a dynamic stability in if you get this right.
I also would point out, I love the build systems chapter in the book. That was great. That was one of the first chapters we got, and we were like, if they're all this good, then we are set. It was wonderful chapter, and because it really steps through the evolution of the build system. First, we start off with a giant makefile, and eventually, with most things that scale, you have to get to a point at which you say, there's a clean break somewhere, right? We just have to rethink the problem. The problem has shifted so much that we have to rethink it from a completely different perspective. And so Because the makefile solution, that we had a makefile, and we had a thing that generator that made makefiles, and then we had a thing that kind of like generated the generator. And at some point, this is just not going to work. This is going to scale super linearly. And so we had to step back and say, what problem are we actually trying to solve, right? And it was we trying to build our software in a scalable way. And from that discussion, out popped, at the time, was a radically different kind of build system in Bazel, right? We've open sourced this as Bazel, and other kinds of declarative type of build systems that actually constrain what engineers are allowed to do. And that is a completely different kind of build experience. People coming into Google are like, where's the makefile? We actually don't have one. This is how actually you declare your build and you make it work. But at the end of the day, like, this solution has scaled much more than the makefile-based solution would scale in any type of way. It's because we had to make that clean break between this old solution just does not work anymore.
Yeah, I think what we've seen, what you're saying is we have these problems of time and scale as we shift left towards giving developers more freedom or autonomy. That's typically a good thing. Are there any other areas within Google that shifting left is working well? And also, is there any areas where you would say, hey, shifting left is actually a bad thing?
So amusingly, I just hosted an internal workshop discussing the left shifting philosophy just recently. And there were a couple points where we realized, yeah, you can't go to something like if you have editor save hooks that go through and delete your unused imports. That might be annoying. I wrote that import. I'm about to go use it. I accidentally hit save and you just deleted the thing. Probably don't do that. That is shifting the fix a little bit too aggressively to the left. But there are a lot of things where we're finding deeper value in having pushed it this way. Like one of my favorites, and it's alluded to, but even my thinking on it was not as advanced at the point that the book was finalized. One of my favorites is a couple pages in the continuous integration chapter, where I'm going to argue that everything that we know about monitoring and alerting in production is directly parallel to unit testing and CI, right? All of the stats, all of the things that you are observing, QPS, disk usage, network, per application statistics, everything that you're using, that you're monitoring in production, right? The same logic and philosophy applies to unit tests. And your CI is exactly the same as your alerting system. And therefore, you can go read all of the SRE knowledge, wisdom, philosophy on monitoring and alerting and apply that to your testing and level up immediately. And that's brilliant. So yeah, there's a lot. We're not done yet by any means.
Great concept there. Totally makes sense. Let's discuss trade-off. Hyrum, at a high level, it feels like maybe every decision, even in life, there's some sort of trade-off that maybe needs to be made. How should we think about it in relation to software engineering?
I had a professor in grad school who said engineering is the science of trade-offs. And this was in electrical engineering or some much more physically constrained, if you will, engineering discipline. But it's the science of trade-offs. We have to make decisions about, are we going to put more engineer time on a specific project to try to optimize it and perhaps save computational resources? Are we just going to throw more computational resources at a problem and not worry about our software? What are we going to choose to spend our time on as we are software engineers as we're doing things? One of the discussions that Titus and I have been involved in a lot internally is around technical debt. And that domain, how do we address technical debt internally? How do we incentivize it? And it actually turns out that a lot of people are really interested in cleaning up technical debt. It also turns out there's a lot of technical debt that you don't need to clean up, that it's an acceptable level of technical debt in kind of the ecosystem. I have a whole other talk you can go find where I talk about like technical debt as pollution in an ecosystem, because there's a much more varied kind of way of thinking about it. But so people say, hey, I cleaned up this thing. I spent my whole week doing this. And we sit back and say that wasn't actually the most important thing for you to do, right? Like you just traded off your time for a thing that wasn't actually that valuable. And so in the software engineering discipline, we need to be thinking about, number one, what are the most impactful things that we can be doing? And then how do we, make those decisions in our organization? And we try to use as much data as we possibly can. If we could make every decision, if we had perfect data, we wouldn't actually need to make the decision because the decision was made for us. We have an automatic system that makes the decision. The reason we pay people and humans to do things is because they need judgment and they need insight, and we don't have perfect information. We have to make decisions and underneath those constraints and move forward. But we also need to be willing to revisit those decisions as the constraints change. So as the system evolves, as the data changes, as our ability to do things changes, we need to be able to revisit those decisions. Several years ago, when we first started doing these kind of mass migrations within our code base, like we obviously looked at the most highest priority ones. What are the things that really matter the most? And let's focus on that. And as we got better and better at this, one day Titus came to me and said, there is a file that has a dash in its name. And that really bugs me. I wish it was an underscore because it was like inconsistent with the rest of the files in that directory. And we actually had data on this. We saw that engineers were mistyping the name consistently, and that was causing build failures, and they had to go back and fix their code, right? All these kinds of things. And so he says, I would really like if we could change this hyphen as a word separator into an underscore. And so we did, right? There was, I think, 50,000 references to this file across the entire code base, but our ability to make those kinds of changes had improved to the point where the decision, should we make that change or not, had changed. We'd gotten good enough at it that we could make that change with relatively low overhead and justify it based upon the very real costs that we could show that people were paying because this hyphen was an underscore, or because we had a hyphen instead of an underscore.
We don't want to annoy Titus, so that probably loaded a lot into that decision-making factor.
Less than you'd think.
A lot of our listeners are having to make these decisions and trade-offs like every single day. As a software engineer, you're making decisions. Do either of you have any tips of what questions you might want to ask yourself in determining, should I do this thing around technical debt or not?
I think the most important piece, especially as we get more experienced in our careers, a lot of people come around to the idea that it is much more important to make a decision that you can undo. Like I'm much less concerned with, is this necessarily the right decision, so much as what are the stakes here? If we make this decision and it's wrong, can we undo it? That's very important. I find most of the questions that I ask to the more junior people in my teams are mostly about, I'm just checking your work and like looking at your reasoning. And I'm perfectly willing to trust you to make those decisions, so long as we have the ability to like change our mind if additional information comes up that like shows that, oh, nope, we're wrong. Okay, let's be honest about that. Let's move along. And I think that actually honesty ties a lot into the trade-offs and decision-making equation of, it is far too easy for people to get caught up in, I'm going to argue that I'm right, and I'm going to base my worth and my career stakes on, yes, I did this thing and I was right. And that's really not engineering. It's really not rational. That's something else. And when we can build a culture around, yep, okay, screwed that up, let's go fix it. Everyone learns, and that accelerates. It's a question of, are you optimizing for yourself in the short term or for the team in the long term? And yeah, that turns out to be real important too.
Yeah, excellent. I'm sure if you're in that mindset that you're in this defensive state, that's going to cloud all of your judgment in decision making. Hyrum, any tips from you on maybe some questions you ask yourself internally or to a junior when making a decision? Should I do this thing or not do this thing?
One of the core things, this is tangentially related to your question, but I think we'll come back to it, that came out of writing the book that we didn't expect, was a discussion around constraints. Mm-hmm. And the fact that chosen constraints of a system, of an API, right, actually are very powerful. And so the question I ask when we're doing design or when I'm reviewing a change or whatever is, what are the constraints that this imposes? Like, how can this be abused by people? Hyrums Law related issues, right? But what are the constraints that we can use to help guide people to the right set of behaviors as they consume this system or as they use this thing? A well-chosen set of constraints turns out to make evolvability much easier in a broader software context. It means you can undo some of those decisions that Titus was just talking about. It means that you're able to guide people in the right thing, being somewhat subjective, but that it's almost better to have folks doing similar things, like consistent in, even if it's not in the perfect thing. And that having appropriate constraints on a system or its evolution are actually really important. So thinking about those constraints, if I'm providing infrastructure, if I'm providing a system to somebody, right, what are the constraints that I would want to put on them. And oftentimes we think of constraints as like limiting. No, I can't do things. I'm being constrained. But I think there's lots of constraints we interact with on a regular basis, right? Like traffic signals being a very common one. Very few of us think that red lights are somehow limiting to it. I'm grateful that the red light tells me that I shouldn't go into the intersection and get creamed by the guy going across the way. These are important sets of constraints in our lives. And if we think carefully about the kinds of constraints in the systems that we're designing, it can be very powerful in providing a long-term sustainable view of the software.
Yeah, most of the chapters, like we seeded it with everyone should talk about time and scale and trade-offs. Almost every chapter surfaced like, oh, and it turns out it's a really good idea for your organization to constrain this. A fair number of chapters were, and I know that Hyrums Law is a thing, but it's a lot of a thing for our problem. That was also amusing. But the constraints thing is counterintuitive because when you're building a product or a platform or something, you're looking for adoption, like you want to support everything, right? And so you try to do everything. And that makes sense. But within the bounds of one organization, the more that you can ratchet things down and lock off the less used pieces, like the more flexibility that you will have for changing decisions in the future without having to deal with the fact that one team picked up this exotic dependency on something that you supported. Hyrums Law applies there too. And yeah, like it's good for within the bounds of an organization in particular to have as few ways to do anything as reasonable.
Yeah, it seems like you'll probably gain a good amount of efficiency, sometimes creativity with constraints and focus, and that's usually a good thing for humans interacting with a product. And
just a quick answer, like just an example, code formatting. People they view their code format as like a very personal thing. There must be tabs and not spaces, and there must be this many, and the brace goes exactly here, all these kinds of things. Very early on, like we introduced a code formatter. Go had one from the very beginning. We added one for C++ when we started doing a lot of automated changes because we had to format the code to look like a person wrote it.
Yeah.
And
Clang format is our fault.
Yeah, Clang format's our fault.
We had to have that in order to get our job.
But once you take formatting out of the equation, right? Like people can just write software, and the whole part of your brain that worries about where does the variable go, like where does the line break go, does the star go on this side or that side of the name, and like that whole part of your brain can be reclaimed for like doing actual important stuff and not worrying about that kind of thing because you've constrained the format of the code. And now I just run a tool and it just does the right thing for me. And I just don't have to worry about it all. Like, it turns out that personally, I don't care about any of this stuff. I just want it to be consistent and I want it to work. And those constraints are really powerful in that kind of context.
Yeah, let's use our brain power on tough problems, not where the semicolon goes. So incredibly, those three pillars that we just covered, time, scale, and trade-off, they might come out throughout the entire book, but focus on the first chapter. It looks like the rest of the book is about culture. You have policies, you have tools. We only have time to dive into one more of those topics. And so let's hit on culture a little bit. So I think any seasoned engineering leader knows the extreme importance of culture. So I'd really like to hear from each of you on this topic. Why is culture so important, and what is something you've learned about it during your time at Google? Titus, let's start with you on this one.
Sure. So there's a culture talk that I've started giving in the last few months that sort of starts out with the idea of think back to how most of us learned, right? Like most of us learned in university or in a boot camp or something. And you're in lecture and you get some slides. You have some assignments and you're told we have to see if you know the material. So don't cheat, don't talk with anyone else about it. So you're going to go off and do your assignment by yourself. The only time that a human looks at your assignment is some anonymous grader that is literally judging. And you iterate on this for a few years and then you get a degree. And then you go off into industry. And it is entirely reasonable, at least in Western universities at this point, for a graduate of a CS program to have not actually ever witnessed a programmer program. Like we have this whole idea of you're just going to be up late at night alone in a dark, and the only time that you ever actually see someone else program. Code must be shameful, right? That is the lesson that we have transmitted to basically every tech grad for the last 20 or 30 years. And then we move them into, oh, congratulations, now you're in software engineering. Now we need you to be thinking not only about the production of that, but how the team is going to maintain it over time. And that is an entirely different thing, right? We need almost immediately a 180 shift from you're going to iterate on this thing in private by yourself forever until it's perfect, to what we actually want Nooglers to do. 2 hours into a thing, show us your work in progress so that we can get a sense of it and nudge you in the right direction so you don't go learn a bunch of bad habits or waste a bunch of time, right? And the more that we can be collaborative, the better. But that's really hard because that also means that you have to be willing to ask questions, be willing to admit that you don't know things. And if you find yourself on a team where people are like, how can you not know this? Then you're disincentivized for, asking questions, and this cycle is deadly. And as I've been saying, loudly and to everyone that'll listen for quite a while now, it's at least as important to be a good person as it is to be a great programmer if you want to succeed in tech. Because as it turns out, just building a team that actually has your back, that is supportive, where you're okay admitting mistakes, so that the team can learn from those mistakes, that team over 6 months is absolutely going to win over a similar sized team of superstar jerks. I'll put money on it. And that is not the message that we give because we don't talk about it. And turns out, I think software engineering is largely a communication and cultural problem on top of, and you have to be, it's also important to be a good programmer, but if I'm hiring, I'm going to try to get a sense of, are you a good person? Because I can make you a great programmer. That I know. I don't know how to necessarily make you a better person. So I'm going to do the one that I'm going to shop around for the one that I don't know how to fix.
Excellent. Yeah, absolutely. And it's a little bit of a shame and can be a big, I guess, culture shock if you're used to being more egocentric. I'm coding on my own. This is my code. I'm afraid to ask a question.
Yeah.
Now I'm getting put into an environment where it's like a collaborative team sport.
Mm-hmm.
I don't know what I'm doing here. So I assume some people maybe don't make that transition and probably not going to last at Google too long. And other people hopefully are able to adapt and start kicking ass with the team.
That's the hope. But and we're not as good at telling people that is the nature of the job as we really should be, because we're figuring this out as we go too. But
yeah, I was certainly never told that in college. I had no idea. Hyrum, same question to you. Why is culture so important, and what is something you've learned about it during your time at Google?
So there's a saying, culture eats strategy for breakfast or something like that. When I was did a bunch of work with the Apache Software Foundation, and they were saying community over code, right? These both kind of encapsulate this notion that without the right culture, it actually doesn't matter a whole lot. You can write good, you can get some software, you can build a product, you can write a thing. But there's a hard upper bound on the complexity of the system you can build if you haven't got the cultural things figured out. I don't think there's a one true culture. Google certainly has a culture, and other companies have cultures, right? There's not a one true culture that you have to have. But I think the successful ones share common characteristics of willingness to be open about concerns, willingness to be humble about things. There's a lot of willingness to make mistakes, willingness to share mistakes. So just yesterday, I had a concern about something a director said in a meeting, and I emailed them and was like, hey, just so you know, this could maybe be taken out of context in the wrong way. And this person emailed me back, hey, I really appreciate that feedback, and I'll try to remember that, and done these kinds of things. Right now, I was really grateful that I felt a little bit out of my league making this observation, but I was really grateful that the response was very welcoming, and even said something to the effect of, we don't agree on everything. And as I thought about that, I'm like, no one agrees on everything, right? It's impossible for everyone to agree on everything. And Titus and I don't agree on everything. That's okay. But yes, being willing to wait a second. Being willing to admit that and to internalize it and to accept that as part of the process is really important. So the more I've learned as I've been doing software engineering for however many years, right, is that this is actually not a technical problem. Software engineering is not a technical problem. And we all love the technology. We love to argue about everything from what's the latest web framework to how many iCache misses am I going to have if I use this instruction instead of that instruction. We love to have those discussions. But the fundamental problems in software engineering, is in almost every discipline known to mankind, personkind, is the people problem. right? The interactions between people, the communication, the how do you help people, how do you encourage people, how do you get them to do the best thing they want to do. I want people to be great and to do the best they can, not because they love Google or they love me or whatever, but because it makes them happy and they want to do their thing. And if I can help them do that as a leader in my organization and whatever else, right, then that will produce better software in the long term. It may take more effort in the short term, but it will produce much better results and solve better problems more efficiently in the time horizons that we're looking at. And that's why I think culture is such an important part of building a successful organization.
Very well said. This has been a really insightful, interesting, amazing conversation. Hyrum and Titus, thank you so much for coming on the pod today.
Thank you.
Thanks for having us.
Yeah, absolutely. We know that your book is out there, Software Engineering at Google, Lessons Learned from Programming Over Time. So everyone go out there and buy that book. Also be sure to join the Dev Interrupted Discord community where we keep this type of conversation going all week long. You can find information about everything we talked about in the links below. And everyone, have a great weekend.